Hey, what's going on? It's Simp. Haven't really done a video in a while, and I was busy. I had a lot of things to do, especially tennis season, and I was coming home later and later every day. But I think that I can break that streak today, and let's do some problems here. Today we're going to be talking about tangents and its properties. Quick thing before I even start, though. I need to draw some stuff. This here is a circle, and it has some properties. Let's call this the center of this circle, and we'll call it point O. There's some key terms that you need to know. The first one, some of them may be obvious, but you still gotta bear with me. This thing right here, it's called a radius. And a radius is basically a line segment that goes from the center of the circle to any point on this circle. So that's a radius. And then you have something that intersects just any 2 points on the circle. Actually, I don't want to do it in this color. That color. And we'll call this chord. And a chord is just a line segment inside a circle connecting any 2 points on that circle. So chords, there are obviously a lot of chords, but there's one special chord that goes straight through the center of the circle. And if a chord goes through the center of a circle, it's called a diameter. And a radius is exactly 1/2 of a diameter. A diameter also cuts a circle into 2 semicircles. And then you have these external lines that just barely touch the circle at 1 point. I like to call this the tangent. The tangent line. And a tangent is just any line or line segment that just touches this circle at 1 point. And that point is, we like to call it the point of tangency. And if we had a segment here, and we call this P right here, and this was R, then segment PR is we call it a tangent segment. Okay, so let me draw just one more radius here in purple. Like that. It's a radius, and it directly intersects with the point of tangency. This right here is going to form a right angle with the point of tangency. A right angle right here. So if a radius intersects with a tangent line at the point of tangency, it's going to be a right angle. So with all of those settled, and we've covered all those definitions, let's get into some problems, and we'll do some properties on the way. So this is my extremely well-drawn triangle, and I'll just label these points A, B, and C. This is page 565, number 4. We're going to draw a circle here, an in-center, if I can even draw one. Hold on. Okay, that's the best I can manage. And let's see here. We'll say that, and they give you D, point D, point E, point F. Right there. And what they tell you is that AC is 30. Oh wait, no, AC is. What they tell you is that AF, they tell you that AF is 10. They tell you that CE is 20, and they tell you that BD is 30. And they want you to prove that ABC is a right angle. Not a right angle, a right triangle. So one property of tangents is that if you have tangent segments coinciding at an external point, such as A here, then those tangent segments are congruent. So AF is congruent to AD. So we did say that AF is 10, and if AF is congruent to AD, then AD is also 10. Similarly, if CE is 20, these tangent segments, CF and CE here, all meet up at this point, so that means that this and this are congruent, so CF is also 20. And then BD is 30, well, so is BE. And now we can just count up all these sides. So AC is 10 plus 20, so that's 30. AB is 10 plus 30, which is 40. And BC is 20 plus 30, which is 50. Now we need to apply the Pythag to this, Pythag theorem, so we can prove that it's a right triangle. I'm just going to divide both sides by 10 here, so we get AC is equal to 3, AB is equal to 4, and BC is equal to 5, just to make this a bit easier. And as you can see, 3, 4, 5 is a Pythag triple, so we don't really need to go into great detail in actually doing the math here. We know that 3, 4, 5 is a triple, so ABC is a right triangle. So I'm just going to do one problem here. The rest you can figure out on your own. This is number 11 on page 565. And it tells us that SQ is equal to 2x, OS is equal to 2x plus 2, and OQ is equal to 3x plus 1. And they tell you, first of all, what is x? So let's just label this for a second. SQ is 2x. Oh wait, no. I'm horrible at labeling. SQ is 2x. OS is 2x plus 2. And OQ, that entire thing leading all the way there, is 3x plus 1. Okay. Well, as you might have known, OS here is perpendicular to SQ, right? Because OS is a radius, and SQ is a tangent segment, so if they intersect, it's going to form a right angle. So this is a right angle, and right triangle rather, and we can prove this using the Pythag theorem, so let's do that. 2x plus 2 squared, a leg, plus the square of another leg, is equal to that hypotenuse squared. Okay, cool. So let's do some math here. It's going to be 4x squared plus 8x plus 4. That's the foiling of 2x plus 2 plus 4x squared is equal to 9x squared plus 6x plus 1. So let's just combine some terms here. 8x squared is 8x plus 4 and that's equal to 9x squared plus 6x plus 1. x squared here is important, so let's just subtract all of this, and I mean all of it, onto this side. So this whole thing is going to cancel and equal 0, and this is just going to be x squared minus 2x minus 3. And we can now solve that. So let's see. What here multiplies to -3, but adding gives -2. Play around it for a while, but you'll get x plus 1, x minus 3 equal to 0. So if you solve for that, x is equal to -1 and x is equal to 3. Shun the negative values. We don't need negative values. So x equals 3. That is the only possible solution to this. So now that we have x, and that's the answer to A, x is equal to 3, we need to find the measure of SQ. SQ, we already saw, is 2x, so it's going to be 2 times 3, which is 6. Cool. OS, we need to find OS now, so that's going to be 2 times 3 plus 2, and that's 8. And lastly, OQ is going to be 3 times 3 plus 2, and that's going to be, I believe, oh wait, no, not 2, 1, and I believe that's going to be 10. And as you can see, 6, 8, 10 is a Pythag triple, so it works out.